Hello everyone, welcome to today's lecture. In this lecture we are going to learn about the anatomy of file write and read. So let's start with the anatomy of file reading in the HDFS. So it means that how we can read the file from HDFS system. So let's get an idea of how data flows between the client interacting with HDFS, the name node and the data nodes with the help of diagram. So in this diagram, suppose this is a HDFS client and want to read a file that is stored on the HDFS storage. So there are several steps that first it open the connection and then it get back to the name node, and from name node it get the location and then read the file. So let's understand each in detail. So the first step is the client opens the file it wishes to read by the calling open method on the file system object. So in this diagram, first step is to call the open method to the distributed file system. Now step 2 is distributed file system calls the name node using remote procedure calls to determine the locations of first few blocks in the file. For each block, the name node returns the address of the data nodes that have a copy of the block. The DFS returns an FS data input stream to the client for it to read data from, and FS data input stream in turn wraps a FS input DFS input stream which manage the data node and name node in input and output. So as in this figure, when client requests for opening some particular file, at that time distributed file system connect to the name node and say that please provide the location of this file. So at that time name node finds the location from its metadata and send it to the distributed file system, and also send a FS data input stream to the client. So by using this, now the HDFS client read the file by using the FS data input stream object. Now the step 3 is the client then calls a read on the stream DFS input stream which has stored the information node addresses for primary few blocks within the file, and then connects to the primary data node for the primary blocks in the file. So as I said that by using the read method, now HDFS client can read the file into the FS data input stream. Now step 4 is data is streamed from the data node back to the client which calls read repeatedly on the stream. So repeatedly the read method is called and the data is provided to the HDFS client. Data is stored at multiple nodes, as in this figure. When client first time call the read method, then it is given to the FS data input stream. Now FS data input stream has the location of file, so based on the location it calls the read method on that particular data node and provide the data to the HDFS client. So in that, suppose data is stored at these 3 data nodes. At that time FS data input stream calls the read method on the first data node and then get the information and provide to the client, same as in FS call read method, and also get the data and provide to the HDFS client. In the step 5, when the end of the block is reached, suppose in this figure there are 128 MB data is stored. So after the end of that 128 data bits, when block is reaches to the end, at that time then finds the best data node for the next block. This happens transparently to the client, which from its point of view is simply reading an endless stream. Blocks are read as with the DFS input stream opening a new connection to the data nodes. Because the client reads through the stream, it will also call the name node to retrieve the data node locations for the next batch of blocks as needed. So what happened that when this block is reaches to the end, suppose here, now at that time the FS input stream finds the best node. Suppose the best node is this node number 3. So it immediately calls this files, immediately calls read on that data nodes and continuously giving data to the client. So client thinks that this is only a one file and stored at only at one location because it continuously getting data, but actually in background the data files is stored at the multiple location, and FS data input stream calls each and every data immediately at the end of the FS input stream calls different data nodes in which data is stored and get the data immediately to the and deliver the data immediately to the client. So that is how the reading process is done in the HDFS. Now the step number 6 is when the client has finished reading the file, a function called close to the FS data input stream. After when file is completed, at that time the close function is called to the FS data input stream, and now it closes the connection with the client. So that is how the reading of the file is happened. Same as if I want to write the data in the HDFS system. So how it can be done? So these are some steps. So let's understand in each detail. So step 1 is the client creates a file by calling the create method, because here we are creating the file. So that is why the first method is to create. Second is a DFS make an RPC call to name node to create a new file in the file system namespace with no block associated with it. The name node performs a various checks to make sure that the file doesn't already exist and that the client has the right permission to create the file. If this check passes, the name node prepares a record of new file, otherwise the file can't be created, and therefore the client is thrown an error like input output IO exception. The DFS returns an FS data out stream for the client to start out writing data. So when here first HDFS client create a connection, so open method is called with the distributed file system. Now distributed file system call the create method to the name node. At that time name node check that if already file is already existed or not. If file is already existed, then it provides an error to the client. Otherwise it provides of an object FS data output stream, and by using this the client can write on the HDFS system. Now step 3 is because the client write the data, the DFS output stream splits into packets which it writes to an indoor queue called info queue. The data queue is consumed by the data streamer, which is liable for asking the name node to allocate a new blocks by picking an inventory of suitable data nodes to store the replicas. The list of data nodes forms a pipeline, and here we'll assume the replication level is 3. So there are 3 nodes in the pipeline. The data streamer streams the data packets to the primary data nodes with the pipeline, and which stores each packets and forward it to the second data nodes with the pipeline. So here the step is here a client start writing the data. Now client only thinks that I am writing in only a single file or only at the single location, but when client call the write method, at that time FS data stream also call the also create a different packets on the different nodes, and as we already learned that this default size is 128 MB. So when client writes the data, at that time one packet is created and the size of the packet is 128 MB. After that it moves on the second data nodes and also creates files on that. So that is how at the multiple location the file is created, and that creates a pipelines of data. Here pipelines means all 3 nodes are connected to each other. Yes, when here a write packet is started, then it is written on this, and then on the second node, and then on third node, and then again on the second node, and again on the first node. Now step 4 is similarly the second data node stores the packet and forward it to the third node on the pipeline, and the DFS output stream sustain an internal queue of packets that are waiting to be acknowledged by data nodes. ACK acknowledgement, ACK queues. So this action sends up all the remaining packets to the data nodes pipeline and waits for acknowledgement before connecting to the name node to signal whether file is completed or not. In this figure, we can say that when here we are writing the data packets, so each and every node sends an acknowledgement that file is written or not. If not, then we can again sign the data bits to write on that file. So that is how we can write on the HDFS. Now second topic is JobTracker and TaskTracker in Hadoop. So JobTracker and TaskTrackers are two essential processes involved in the MapReduce executions. So both processes are now deprecated in MapReduce version 2 and replaced by Resource Manager, Application Master, and Node Manager daemons. So now this process is replaced with this different names, but different resources. But at a traditional it is called the JobTracker and TaskTracker. So let's understand each in detail. So JobTracker. So JobTracker process runs on separate node and not usually on data node. So here JobTracker is only running on the separate node. It is not running on the data nodes. It's, as the name suggests, its work is to track all the jobs running on the HDFS. So JobTracker receives the request for MapReduce execution from the client. JobTracker talk to the name node to determine the location of data. JobTracker finds the best TaskTracker nodes to execute tasks based on the data locality and available slots to execute a task on a given node. Suppose MapReduce provide one task, so the task is already assigned, is directly assigned to the JobTracker. Now JobTracker talk to name node and finds it on which location the space is available, and we are executing that task. So JobTracker gives the task to the TaskTracker, and also additional information is also provided of location, and then TaskTracker execute the task. So that is how the JobTracker is work. Now JobTracker monitors the individual task trackers and submit back to the overall status of the job back to the client. So when the JobTracker is down, the HDFS will still be functional, but the MapReduce execution cannot be started and the existing MapReduce job will be halted. So here JobTracker is directly connected with the MapReduce. So in case if JobTracker is down, so other functionality is working, but MapReduce can't be worked or MapReduce can be executed. So at that time, no new MapReduce is executed, and the existing MapReduce will be halted. Now second is TaskTracker. So let's understand what is the functionality of TaskTracker. So TaskTracker runs on data node, mostly on all data nodes. So here JobTracker is running on a separate nodes, neither in a data node or nor in the name node, while TaskTracker running on all the data nodes. Mapper and reducer tasks are executed on data nodes administered by TaskTrackers. As I said that when the MapReduce task is performed, so that is performed by the TaskTracker. TaskTracker will be assigned a mapper and reducer task to execute by the JobTracker, and the task is provided to the TaskTracker by the JobTracker. TaskTracker will be a constant communication with JobTracker, signaling the process of task in execution, and TaskTracker failure is not considered fatal. When TaskTracker becomes unresponsive, JobTracker will assign the task executed by the TaskTracker to the another node. So sometimes it happens that the TaskTracker is not working. So at that time, JobTracker finds that if TaskTracker is not working, then no other process is halted, but JobTracker finds another node, another TaskTracker, and provide to that task to the other TaskTracker. So that is the functionality of JobTracker and TaskTracker in the Hadoop. Now the next is configure SSH for Hadoop. Suppose if I want to install the Hadoop. So what types of configuration I need to what type of configuration I have to do? So Hadoop requires a SSH access to manage its node. For our single node setup of Hadoop, we therefore need to configure SSH access to the local host and the for the HD user. So now let's understand how to install the SSH server and client. So for that there are two main command, which is a sudo apt-get install OpenSSH client and OpenSSH server. So we need to install two SSH, which is a client and server. Then after we need to configure, so configuration passwordless SSH. So for that we need to configure SSH access to the local host for the HD user. So here for that the command is sudo gedit get/etc/ssh/sshd-config. Now here note that set public key authentication need to be yes. When you write this command, there is one dialog box is pop up, and on that you need to click on the yes. And once the changes are made and we need to reload that file, so for that the command is sudo /etc/init.d/ssh reload. So this command is used to reload that file. So first we have to generate and now the first we have to generate the SSH key for the HD user. So for that we need to create one Hadoop user, and for that the command is su hd user. So and next you ask for the password for that Hadoop user. So Hadoop is a SSH which would normally require the user to enter a password. However, this requirement can be eliminated by creating and setting up a SSH certificate using following commands. If you ask for the file name, just leave it blank and press the enter to continue. So for that, there is a two method. One is a password based and it's a passwordless. So in the password based, you need to write the password, and if you don't want to write the password, so at that time you can use a certificate, and for that you need to create a SSH key. So for that the command is ssh-keygen or the ssh-keygen-t rsa-p. So it creates a RSA key. So the second line will create an RSA key pair with the empty password. Generally using an empty password is not recommended, but in this case it needed to unlock the key without your interaction. So you don't wait. So if you don't want to enter the password every time Hadoop interacts with its node. So here as in this screenshot, you can see that here we will reload the file, then we create a Hadoop user, and after we'll create the SSH keygen, and this creates a RSA key pairs. So before cluster setup, we need to configure our nodes. The nodes are name nodes and data nodes. So after this, we need to configure the name node and the data node, and for that some other steps is also there. So and then after your Hadoop configuration is done. So here are some since we are using a single node cluster, we need to configure only one node, and for that the steps are: first step is sync all the nodes with time zone using NTP, and this will ensure that your server is operating under the correct time. So first is we need to change the time zone, and second is set the localization settings for your server and configure the network time protocol NTP synchronization, and then we need to synchronize our nodes over the Hadoop. So these are some steps to configure the SSH for Hadoop. Next is the HDFS monitoring and maintenance. After you install the Hadoop and you create your data nodes, name nodes, and your task is running on the Hadoop, so we need to maintain that task. So HDFS administration includes monitoring the HDFS files, structure, location, and the updated files. MapReduce administration includes monitoring the list of applications, configurations of nodes, application status, etc. So let's understand. So HDFS contains the user directories, input files, output files. Use the MapReduce command like put and get for storing and retrieving. So after starting the Hadoop framework by passing the command start-all.sh. So this is command by using we can start the Hadoop framework. and we need to write this command after changing our directory to Hadoop home directory /sbin, and then we have to write this command. So, and after pressing the enter, your Hadoop framework will be started. Now pass the following URL to the browser, and this URL is because your Hadoop is now on the local host, so HTTP call a local host, and the port number is 50070, which is the default port number for the Hadoop. And when you enter on your browser, then the screen is shown here. So this is the Hadoop. This is the screenshot of that screen which shows how to browse the HDFS. So this is a home page. Here are some menus like overview, data nodes, snapshots, startup progress, some utilities, yes, and here the summary is provided on the home page. Now on the data nodes, your data nodes are running and all the information is shown there. So this is a screenshot of data node information in the cluster, and here you can find the node with its configuration and capabilities. So here you can see that your local host is your node which is alive. Here the block size is 115 MB. Non-DFS used is 1.31 GB. Yes, so this is how all the information we can monitor by using this screen. So that is how we can monitor HDFS, and we can also maintain by using this interface only. So that's it about HDFS. Thank you so much for listening.